Okay, so we're going to continue with the ionic formulas. This time we're going to learn how to name them. So right here, I have this formula right here. It says Pb, Pb. You're going to come into your periodic table of ions and find Pb. Pb is right here. Now look, let me erase this so that you can see. Pb is available in two charges. We have +2 and we have Pb +4. This right here is Cr2O7. Cr2O7 is right here dichromate, which has a -2 charge. So what I'm going to do is, we don't know which Pb that is, okay? So we're going to try to create a bond with Pb +2 and Cr2O7 -2. And then we are going to do Pb +4 and Cr2O7 -2. When you swap the charges, you make this bond, you get PbCr2 Cr2O7 parentheses 2. Notice you can factor this 2 out, okay? This 2 went over here at the bottom of the Pb, which is right here. This 2 went over here at the bottom of this whole thing. You got to put parentheses when the polys are going to be more than 1. So the 2 gets factored out. Basically, you're just left with PbCr2O7. Let's come over here. That's not the formula we have. We have PbCr2O7 parentheses 2. Okay. So when we swap these charges here, you get Pb2 parentheses Cr2O7 4. Now you can factor the 2 out and you will have Pb parentheses Cr2O7 parentheses 2. And that's the formula we have. So you're going to write down the name, because these transition metals right here, some of them have multiple charges. You need to tell the reader what charge this Pb has. Name of Pb is lead, and now we know that in making of this formula, Pb with a charge of +4 was used. Okay, so you're going to put lead, parentheses, IV is the symbol for Roman numeral 4, and then you're going to put dichromate, which is the name of the polyatomic right here. Let's look at the next one while I erase this real quick. Next one is FeOH parentheses 3. Same thing. Look, Fe has 2 charges. One is +2 and OH is your hydroxide. It's right here. It's -1. OH -1. You're going to swap the charges and you are going to get FeOH parentheses 2. Okay, but that's not what we have here. We have FeOH 3. So let's look at Fe with a charge of +3 and OH -1. Here we go, and you're going to get Fe with that 1. We don't need to put that, okay? You see 1 is there. OH is going to get the 3. So now you know this formula comes from using Fe with a charge of 3. So you're going to put iron, Roman numeral 3. This is 1, 2, 3, yep. And then OH is named hydroxide, okay? You see this right here, hydroxide, and you're just going to put hydroxide. Okay. All right, let's do one more. Let's do this one right here, K2Se. K2Se. K has the name potassium. And how do I know this is not poly? Because it only has two symbols. When it has 2 symbols, 2 elements like that, that's not a poly, okay? So we have potassium. Let me write this again, that's kind of weird. Potassium, and Se is going to be right here. And I already give you the ion name. Normally it's selenium, but because it's an ion, nonmetals get the name change with the ending adding "ide." So this is going to be selenide. Okay, let's look at let's do this one. NH4 NO3. NH4, actually this is very simple. I don't even need to do anything here. This is ammonium. You're just gonna put ammonium. So these right here, you have two polyatomics, ammonium, and NO3 is going to be nitrate right here, nitrate. They both have +1 -1 charge. The charge gets cancelled, and that's what you have, ammonium nitrate. Okay, look at this one, AlPO3. Oh, potassium selenide. Al is aluminum. All right, aluminum. It's only when you have to do transition metals where there are multiple charges is when you need to put down the Roman numeral. Other than that, you don't need to worry about the Roman numeral, okay? Only when you have that, because they have these multiple charges, that's where you need to tell your reader which charge metal was used in making this formula, okay? All of these, wherever you see, they have multiple charges. So aluminum, PO3 is once again your polyatomic, and that is right here, aluminum phosphite. Okay, now this is an interesting one. Let's take a look at its formula. Aluminum, if you look over here in this periodic table, is right here. It has a charge of +3. And then phosphite, PO3, phosphite is right here. It has a charge of -3. When you swap the charges, notice they're the same. It's Al3PO3 parentheses 3. This 3 comes here. This 3 goes right here. Notice the 3's can cancel, and all you're left with is AlPO3. Okay, I hope this video was helpful. Let me know tomorrow if you have any more questions.